Okay, Year 12. Next up in alcohols, we're going to look at a couple of reactions that alcohols can undergo. First up, we're looking at dehydration of alcohols. It's called dehydration because it's removing the alcohol group, so the OH, and it's also removing a hydrogen, and it's getting rid of it, and it's leaving it as now a double bond. Now you'll notice that if you look at the reverse of this reaction, so water plus, in this example, ethane, we're looking at the addition of water across the double bond, okay, which is sometimes called hydration. So we're looking at the dehydration, so the reverse of that. We take an alcohol and we convert it back to a double bond, okay? Now, one note for this, we need a catalyst to do it. And here, I would like you to remember concentrated sulfuric acid and heat. It takes an awful lot to make it go the other way. Remember, to make it go the reverse, we need a dilute sulfuric acid. To make it go in the reverse, we need concentrated sulfuric acid and heat. Okay, so they're written just above and below the arrow here. Okay, so my example that I'm using is I've got ethanol, concentrated sulfuric acid and heat, and the products that I get are ethane and water, okay? And so here I've got it in a ball and stick model just underneath as well. So there's a very, very simple dehydration reaction. Here's a couple more examples that are a bit more complex, but still dehydration reactions. Well, I've got, in this top one, we've got 1, 2, 3. So we've got propane, 2-ol, okay? And we're going to dehydrate it, concentrated sulfuric acid and heat, and we're going to add a double bond in there. Now here it didn't matter which double bond went in because it's symmetrical either way. So now we've got I just call it propane. You don't even need to put a number in it. Okay, so propane and then water. I had to think about that a bit too much, didn't I? Okay, second example. Here I've got a cyclic, so I've got cyclohexanol. And then we're dehydrating it, so it's going to cyclohexene. I don't need a number there because I know because of cyclo, the double bond is always in between my arbitrary 1 and 2. 1 and 2, or 2 and 1 the other way. It's symmetrical. And water. So cyclohexanol going to cyclohexene and water. All right. So there's dehydration. Remember, it's the reverse of hydration. Hydration needs dilute sulfuric acid. So here we're upping the ante. It doesn't like going back this way as much. Concentrated sulfuric acid and heat. Okay, let's look at another one. Here we've got a substitution reaction. We talked about substitution before when we were talking about alkanes. Here we're substituting the alcohol group off there for a halogen. So here in my example, I've got methanol and hydrogen bromide, and we're going to do a swap of the partner there, okay? So the OH is going to go over the H, and the Br is going to take its place. So now instead of methanol, I have bromomethane. Did I say ethanol? Methanol. Now I've got bromomethane. So the bromine is in place of where the alcohol was. The alcohol group has now gone with the hydrogen, so I've got water. Okay? This one doesn't, a catalyst is not needed for this reaction. Okay? Alright, so reactivity. So the reactivity between different alcohols, okay? Tertiary alcohols, remember our classification, primary, secondary, tertiary. Here it's tertiary because it's that host carbon is connected to 1, 2, 3 other carbons. Secondary, 1, 2. Primary, 1. Okay, so reactivity is that with substitution is that tertiary is the most reactive, and that primary is the least reactive here. Okay, so secondary, it's in the middle. So here, in between these three reactions, all I've changed is primary, secondary, tertiary. I've kept it as the same hydrogen bromide, and we're getting our products there. But the most reactive, the quickest, would be the tertiary. Okay. You can also get different reactivities in the hydrogen halogen group there. Okay. So here, what I've done is I've kept the same alcohol, propane 2-ol, and I've changed the identity of the halogen. So we've got hydrogen iodide, bromide, chloride, and fluoride, and the heaviest is the most reactive there. So the iodide first, the bromide will be slightly slower, the chloride slightly slower, and the slowest would be hydrogen fluoride. Okay. A good way to remember those, the biggest number here, the biggest number there in the primary, secondary, tertiary goes the quickest, and here the biggest mass goes the quickest. So with these two, I kind of link them together, and I think biggest goes quickest. Don't know if that'll help you out. Okay, examples. Draw a structural equation for the dehydration of propane 1-ol. Okay, so let's draw propane 1-ol. 1, 2, 3, meth, eth, prop. Okay, so there's our backbone. We'll have the alcohol of our number 1 there. So we'll put our hydrogens in. And it's a dehydration reaction. So we got our reaction area. The conditions were, didn't like to do this, so it needs concentrated H2SO4 and heat. Sometimes you'll see heat represented by a capital delta, isn't it? Yeah, a capital delta too. Okay, so we're not going to change the backbone. We're going to get rid of the OH, and we're going to add a double bond in. So getting rid of it from the 1 position, we're going to add a double bond in between the 1 and the 2. We're not changing this carbon on the left-hand side. And 1 and 2. Okay, so I've got, and don't forget the water byproduct. So the propane 1-ol goes to propene and water. Alright, I think I did good there. Draw a structural equation for the dehydration of but1-N-ol. Alright, let's see how we go. I don't think I tested this one before putting it in. So it's a but, so we've got 4. What a beauty. Terrible joke. 1-ol. We've got our alcohol group there. 1N. Alright, so that's what we're starting off with. Oh, I've drawn it really big, haven't I? I can't really go across. Okay, let's put our hydrogens in. To make our but1N1-ol. Okay, there we go. And it's a dehydration reaction. I'm going to draw it going downwards. We need concentrated H2SO4. And we'll need some heat as well. Okay, draw the backbone in. We're not changing the backbone. Okay, I'm even going to put that double bond in there because we're not going to take away that. We're going to add on, we're going to get rid of the hydrogen and get rid of 1 there. Alright, so, oh, my angle's not good. I'm not showing my proper carbon hydrogen angles, am I? Okay, plus water. I should erase that. That makes me feel better. Do my hydrogens there. Okay, so what have I got? I have got meth, eth, prop, butene, but1-ine. Oh, help if I could write. But. I need to put the 1 in there because it could be but2-ine, couldn't it? But1-ine, and water is spelt like that. I don't know why I'm spelling it out. Terrible. Alright, I think I'm good there. That worked well. Draw the structural equation for the substitution reaction between propane 2-ol and hydrogen chloride. Alright, meth, eth, prop for the backbone. 2-ol, so on the second position, we've got our alcohol. Let's put in our rest of our hydrogens now that we've got everything on there. And we're doing a substitution reaction, so swapping it out. We're swapping it with hydrogen chloride. Notice I put a little bond there, it helps me recognize it. So what's going to happen is these guys go with that guy, and this guy comes in there. I don't know if that helps out. Alright, so backbone stays the same for my organic. Okay, in the 2 position now I have a chlorine. Okay, nothing else changes. Hydrogen, 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 hydrogen. 3 on the left here. And the H and the OH come together to form water. Okay, so I've got 2 chloro propane. Okay. Alright. We didn't need a catalyst for that, so checking catalyst, we're all good. Another example. Draw the structural equation for the substitution reaction between butane 2-ol and hydrogen iodide. Okay. Meth, eth, prop, but, 2-ol. Okay. Put my hydrogens in. Hydrogens. And what are we doing? Hydrogen iodide. Okay, so it's a substitution. I'll change my colour. The OH is going to go with the H, and the iodine is going to swap it in there. So same backbone. 1, 2, 3, 4. So we now need an iodine here. I was going to say iodide. Iodine, everything else remains the same. And our byproduct is water. H with the OH. Okay, so we've got 2-iodobutane. Alright, don't need the catalyst for a substitution. Okay, so now you can do the worksheet on dehydration and substitution of alcohols. Okay, thanks guys.